everyone, let's see this particular question. So here the question says that if a is equals to a limit is given and b is equals to another limit is given, and we are supposed to find a b cube after solving these two limits separately. So let's work on a first. A is equals to limit x tends to 0 under root 1 plus, again one more root is there, 1 plus x to the power 4 minus root 2 over x to the power 4. Now if we will substitute x as a 0 directly, then let's see what is happening. So if we are substituting x as a 0, then we are getting 0 by 0, which is indeterminate form. So we will use another approach. Let's see what can we do. So suppose we are doing the multiplication with this entire root. Let's say this is x, entirely it is x, and root 2 is y. So can you see x minus y structure is there? We can multiply numerator and denominator with x plus y, the way you do rationalization. Okay, let's do that. So yeah, this way we can do the multiplication. Can you see the highlighted part? Okay, now we will multiply numerator with numerator and denominator with denominator. So after doing the multiplication, in numerator we are getting a square minus b square, and the denominator will remain same. So after doing the squaring, the bigger root, only the bigger root will vanish, and we will be having 1 plus, the smaller root will remain as it is, 1 plus x to the power 4. Okay, and minus 2 over denominator will copy paste as it is. Let's simplify the numerator. Limit x tends to 0. When we will open the bracket, this minus 2 and 1 will get simplified together, and we will be getting minus 1. So root 1 plus x to the power 4 minus 1 over x to the power 4, and the denominator we will copy paste. Now if we will substitute x as a 0, still we will be getting 0 by 0. So one more time we need to repeat the same process. Again, can you see in the numerator a minus b structure is there? We can multiply numerator and denominator with a plus b. Okay, just like rationalization. Let's continue. Like this. Now in numerator we will multiply, and we will be getting 1 plus x to the power 4, that means a square, minus b square, that means just 1. Yes, limit x tends to 0 still we are having, and denominator will remain as it is. We don't need to do anything with the denominator. Let's keep it as it is. After simplifying, we are getting just x to the power 4 in the numerator over x to the power 4 and we can clearly see x to the power 4 from the numerator and x to the power 4 from the denominator will cancel out each other. Now we will substitute this x as a 0, and we will check what are we getting now. So now when you will substitute 0 at the place of x, let's see what are we getting. We will be having under root, 1 will remain as it is, again one more root is there, then 1 plus 0. Okay, plus root 2 will remain as it is. Then other bracket we are having 1 plus 0 plus 1. If we will simplify it further, we are going to have 1 over, a bigger root sign is there, 1 plus root 1 is just 1 only, so we will just take it out, and we are having 1. Okay, 1 plus 1 inside the bigger root, root 2. One more bracket is there, and in that bracket again root 1 plus 0 means root 1, that means just 1. We will be having root 2 plus root 2 over here, and that is just 2. That means we will be having 2 root 2, and other bracket is having just 2. So basically we are getting a as 1 by 4 root 2. Okay, Now we have to solve b. Another limit is also provided which we need to solve first. So b is given as a limit x tends to 0 sin square x by root 2 minus root 1 plus cos x. Let's solve it. So yeah, this is our b. Here again we will substitute directly x as a 0 in the numerator, sin 0 is 0. And if we will substitute x as a 0 in the denominator, root 2 minus 1 plus cos 0. Cos 0 is again 1. So 1 plus 1 will be root 2. Basically again we are getting 0 by 0, that is indeterminate form. So we have to use another approach to solve it. So yeah, here we can also use the same process just like rationalization. If you have solved questions from limits, you must have used this approach very often in most of the questions. So yeah, let's use it. So we'll be multiplying numerator and denominator with root 2 plus under root 1 plus cos x. Similarly, the denominator root 2 plus 1 plus cos x. Let's see what are we getting. Limit x tends to 0 sin square x. In numerator we'll keep the terms as it is. And in denominator let's do a square minus b square. So a square root 2 square will be just 2 minus root 1 plus x square will be just 1 plus x. Cos x I mean. So we are going to have sin square x. Numerator again will copy paste as it is. And denominator 2 minus 1 minus cos x. So we are getting 1 minus cos x in the denominator. Now the numerator sin square x, let's write it as a 1 minus cos square x by using the identity sin square x plus cos square x is equals to 1 root 2 1 plus cos x. Now this numerator's 1 minus cos square x, let's write it as a in one bracket 1 plus cos x, in another bracket 1 minus cos x by using the formula of a square minus b square. So in one bracket 1 minus cos x, a minus b, a plus b. One minus cos x in the denominator. This 1 minus cos x, 1 minus cos x will cancel out each other and we are having all terms having just positive sign, addition sign in between. Now if we will substitute this x as a 0, I hope we will be getting the answer for b as well. So b is equals to, we are going to substitute x as a 0. So 1 plus cos 0 root 2 plus under root 1 plus cos 0. Cos 0 is 1, so 1 plus 1 root 2 1 plus cos 0 again 1. So we are getting 2 and here we are getting root 2 plus root 2, that is 2 root 2 multiplied with 2. So we are getting 4 root 2. Our b is 4 root 2. We are supposed to find a b cube. Let's substitute the values. So our a was 1 by 4 root 2, 1 by 4 root 2 times b is 4 root 2, just 4 root 2 whole cube. We'll do the multiplication. We are getting 4 times 16 and root 2 into root 2 is just 2. So we are getting 32 as a final answer. Let's check the options. So yeah, here option 4 is 32. This is the correct option. I hope you understood the entire process. If you are having any confusion, please comment in the comment box. Thank you.